Howdy and welcome to part 2. A new theoretical explanation about these relationships. Yeah, this first sentence has to get worked on a bit. First, we should think about the creation of mountains from a totally different perspective than consensus theory suggests. No, it doesn't. Most likely, the Alps weren't created by plate tectonic movement. Their creation process involved electricity and water and a lot of both. We assume modern Central Europe was transformed by multiple processes into the landscape seen today. In the northern part, in Germany, we find the Eifel volcanic regions. South of the Alps, in Italy, we find the Phlegrean fields. Both had strong eruptions about 12,000 years ago. It could also be that the Eiffel complex came into existence only 12,000 years ago, or less. So, with that being said, we must take into consideration the possibility that the Alps were created simultaneously with the birth of possibly one of those two volcanic regions. As earlier explained, Earth has many layers. One of those layers or shells are the L shells. L shells are planetary magnetic field lines which usually span from pole to pole. Much scientific work has been done about Earth's circuits, for example, the pole regions. We also have to keep in mind that Earth's axis has not always been in the direction it is now. Interplanetary encounters happened, and many other things which left their scars on the surface of Earth and below it. All these past events affect the Earth's electric circuits in their complexity. Earth is making the connection to the Sun by its poles, so they are very important to understand. About the relationship about north-south circuits of the East Pacific Rise, Southeast Indian Ridge, Mid-Atlantic Ridge, and Western Pacific Rim is written in a great paper by Bruce Leyburn. Here is one picture of this paper. The North Pole circuitry. It is very important to understand that electromagnetic fields are coupled, i.e., there is no electric field without a magnetic field, and where you find a magnetic field must be an electric current. If the magnetosphere gets compressed, those different layers may break, i.e., disrupting connections, because this releases a large amount of energy. The energy which was flowing in the layer might have been somewhat local events which were happening elsewhere on Earth too. But as all other natural events, they represent only a part of the bigger chain of events. The events of these disruptive events deeply impact the environment. As a possible proof for this claim, we can examine volcanoes on both sides of the arc. There are basically holes burned through the mantle by a very strong electromagnetic discharge event, making the connection to the deeper layers where we find magma and hot water. Even though the actual event is over, the energy exchange between ground and atmosphere continues. It doesn't have to be always a volcanic eruption. Very often we find that these spots influence weather patterns. Giovanni Gregory has done extensive work on the Earth-Sun connection theme. The following picture illustrates the continuous connection between ground and sky, which is therefore a circuit and will react immediately according to the environmental electromagnetic changes. The environmental changes Earth's experience are mainly driven, there's a L missing, driven by the Sun and the Sun's environment, changes according to the changes in the connection to the center of our galaxy. That's a picture from Giovanni Gregory's paper. There are also possibilities for having strong electromagnetic discharge events, such as close cosmic encounters with other planets or asteroids, which are big enough, as described by Immanuel Velikovsky. Many landscapes have been shaped by these events, but the evidence in terms of the creation of the Alps points more to the solar cycle. The planetary body interfering in cycles is actually a cosmic dust cloud. The cosmic current sheet. Otherwise, the mechanics of massive discharge events between the heavens and the ground are basically the same. In the case of the Alps, I think the creation included ground to ground discharge. The main driver for this to happen is the sun. So it is something which will be reoccurrent. The 12,000 year cycle of the sun is maybe the most influential of all of the sun cycles. A recurrent micronova event. It is not too long ago when also mainstream science admitted that there are many other kinds of novae too, not only supernova, for example, micronova, like described in a recent paper. Our sun is a star, so there is no reason why it shouldn't behave like all other stars do. Yeah, that's really recent. Few weeks. We have volcanoes on both ends and a huge mountain range in the middle under which lies a strong geothermal activity. I think there are two kinds of ground to ground discharge events possible. One burns holes on both ends and creates mountains in the middle, and the other one creates mountains on both ends and a hole in the middle. The hole might be a river system, lakes, or a volcano. In case of the Alps, we are probably looking at the first example. In order for electric current to flow, it needs something conductive. Earth's mantle has a huge amount of water stored inside. If the environmental conditions are suitable, the water rises upwards, and since we have electric currents underground, water will eventually make and maintain the connection between the heavens and earth. I think it is important to understand what maintaining the connection means, i.e., the water is binding things together. E.g., a handful of dry sand is difficult to keep in your hand. It is almost impossible because it runs through your fingers. If the sand is wet, it sticks together and is even formable to some extent. During the event which possibly created the Alps, loose material got sucked upwards in very strong electromagnetic currents, ionic winds. These currents produce super strong winds. They can be supersonic and strongly ionized with wide variations. The water from inside the crust was making the connection upwards to the heavens and made other materials stick to it, like the water droplets in the sky which catch all sorts of materials such as volcanic ash. As the groundwater is rising upwards and carries other matter with it, at some point it starts to evaporate, and all the matter which doesn't evaporate starts to pile up and it gets electrically altered and fused together. We call this transmutation. See Edo Kyle. The stream of water from below gets eventually weaker as higher it gets and more material accumulates at the base of it. Hence, a mountain is being formed. These events are full of movement and somewhat chaotic since everything is following simple principles in a rapidly changing environment. In some occasions, the electric current comes to a halt and as it sweeps over the land, and it kind of establishes a relative stable connection to the ground. Its stability and therefore a longer durability, the connection from the groundwater layer upwards might not be the highest in altitude but the strongest. After the connection breaks down, there will remain a far larger channel where the water was flowing. This also means that the amount of the outflowing water is larger than in other places. In places where the connection was held in place by continuing for some time, we can find crater-like structures which are very often filled with clear water and have crater-like shapes. Water played an important role in the process of the creation of mountains, and I think there could be something like a hollow fulgurites inside mountains. They weren't hollow at their creation. Water was flowing in them, probably very hot and dense water since it was part of a Berkeley current. The remains are vitrified connections from the peak of a mountain down to the groundwater. They are possibly very fragile and can be destroyed by earthquakes, but thousands of them are still functioning. The connection is still there, but on a much lower energy level, which also indicates that the process is still ongoing. Where glaciers start to grow. The source and the root of the glacier depends on the geographical location of the spring, elevation above sea level and latitude, whether there is a glacier forming or not. If the spring is located in a permafrost area, the possibility of a glacier forming is suitable. We know that climate changes, so did It did so in the past, and it will do so in the future cycles too. The water feeding the glacier is slightly warmer, not frozen, than its surroundings, otherwise it wouldn't flow, pushing the glacier downhill. Glaciers are rather short lived lava streams made out of water. Mountains are peppered with springs. Some are just normal springs, and some are rich in minerals, some are hot, some are almost on mountain peaks, and somehow some are even radioactive. I grew up in Switzerland, in the northern part at the end of the Jura mountain range, where you find the hottest and most rich in minerals thermal spring in Switzerland. In school, we learned how Alps formed, from one plate crashing into another, and how all the water comes from the mountains. It is either melting water from the snow which accumulated in wintertime, or it is water coming from the melting glaciers, which is basically the same. Precipitation is only partially responsible for glacier formation. I think they are mainly fed by groundwater. Like weather, it has its own climate and fluctuations. Geothermal activity doesn't mean only warm water, it is usually also an indicator of mineral rich water, i.e., the overall indigenous energy potential is high. If the distance between groundwater and spring is long, the heat loss of the rising water will be noticeable and it might have also a different chemical composition, not only because its temperature loss, also through the change in geological environment and of course the height difference. The water rising up inside the mountains may have originated several kilometers underground and several kilometers above sea level. Factors like height difference between groundwater level and the spring, different sedimentary layers, rock types, or the condition of the connection itself, hollow fulgurite, are all influencing the behavior of the spring. There are basically two kinds of glaciers: alpine, mountainous, and ice shelf glaciers. Both are flowing. The questions must be asked. If alpine glaciers flow because they're on a sloped surface, why do glaciers on a level surface flow too? If glaciers, according to common theory, carved out all the valleys, where are the piles of gravel and rock? Why do we often find lakes where the glacier has once begun? Frequently, also mudslides and flash floods are in the news. Usually, the official explanation is heavy rainfall in the mountains. I think generally this seems correct, although in some instances that mudslides or flash floods may don't need rainfall to occur. In the proximity of volcanoes, they are called lahars. But we don't have any listed volcanoes within the Alps. Is it possible that something very important got overlooked? It might be also very well possible that the water which is coming downhill into the valley has its origin underground. Groundwater gets pushed up to the surface quite much like a geyser. The forming of glaciers needs two things: water and cold temperatures. A slope or a downhill landscape is not required to form a glacier. Maybe just the fact that the water rises so high makes it easier to freezable. This combined with some minerals could also make melting, freezing temperature change. This could have also influence of the viscosity of water in both states, frozen and liquid. The boiling point of water lowers with rising altitude above sea level due to pressure changes of the environment. This is a very important hint for the importance of having so many mineral water springs. Minerals have their own frequency and therefore also a charge potential. Water which is pouring out of a mountain has undergone several changes in its composition while it was flowing upwards. It depends not only on the spring and its connection downwards of how strong it will react to the changes in its electromagnetic environment. Very important is also to take the larger electromagnetic environment into the picture. Things like surface conductivity anomalies, magnetic anomalies, rivers, lakes, and mountain ranges are important to understand in terms of the geometrical shape of magnetic fields. Simply put, mountains are north positively, and valleys, lakes, rivers are south negatively charged. It is crucial also to notice that the areas change in form and strength in altitude and depth. These areas of different charge create electromagnetic fields, and weather interacts with them. Some of the water or ice accumulates through snowfall. Glacier ice is usually bluish in color and is often quite pristine. If glaciers are formed only by accretion from above, we would expect to find all kinds of impurities also deep within the glacier. We also would expect some kind of year rings in the different layers if the ice formed by the snowfall in wintertime and melting in the summertime. But glacial core ice is very homogeneous, which is explained commonly by the high pressure due to snow and ice column on top. We also have glacial caves, some of impressive size. The official explanation is that melting water carved them out. The melting water is getting more and more due to human induced climate change, according to common theory. But what if the heat is coming from underneath the glacier itself? If we have a deep ground connection underneath the mountains, where water pushes up to the surface, we have a current. Currents carry or represent energy flow which has a magnetic field. This means we should find all kinds of activities which first don't seem to be related to each other, like chemical reactions, hydrodynamics, weather phenomena, social activity, history, geology, and so forth. We won't dive into all of them, but it is crucial to understand that all chemical reactions are electrical and life on Earth depends on water. So they are all interconnected. What was going on when the Alps got formed? Planet Earth is shaking by very strong winds, quakes, volcanic eruptions, groundwater which has risen up to several meters above the ground. Very strong winds are blowing, heavy lightning. The magnetosphere is wobbling strongly, and through that, very much energy has the possibility to come into Earth's electrical circuit. Eventually, the lowest L shell gets so strongly compressed that it breaks and releases a huge amount of energy in form of an electric magnetic discharge event. A ground to ground discharge event, an arc between two places on the ground. The following picture is a comparison between Earth and Sun. On the left side, we have a close up of a solar flare, and similar mechanics could have created the Alps. The amount of energy needed to make something like this possible to happen on Earth can easily be provided by the Sun, especially during the cycle changes. Yeah, I think that's a cool picture. The Alps are here. This would be Eiffel. This, the lower one, would be completely gray. But anyway, in case of the Alps and their creation, I think it could be possible that the places where the arc grounded or made the connection to the ground have been the Eiffel volcanic complex in the north and the Phlegarian fields in Italy. In between, we find the Alps. Like earlier already mentioned, the process of the creation of the Alps cannot be seen as a single event which happened only at the place of action. It is a small part of a much bigger picture, many more discharge events and storms in the same area interfering with each other, and so forth. So it is just one event of many which are all related to each other, which also means the patterns left aren't geometrical but recognizable and, most important, repetitive, as shown in figure 12. The patterns we are looking for are Lichtenberg figures, or also called dendritic patterns, layering patterns related to tetrahedrons, and of course also craters. These patterns indicate the driving force behind the event was electrical in nature. A valley near Bolzano, Italy, with a repetitive pattern. Here, that's the same thing, it's just turned around 90 degrees. We find that big rivers like the Rhine, Donau, Po, Rhone, and others have their source in the Alps and end up in the sea. This might be of some importance because we speak about salt and fresh water making a connection. Salt increases the conductivity and energy surges for the path or path of least resistance, perfect conditions for electricity to flow. This connection might also be a part of the reason why we find salt deposits in Central Europe. It got carried there by currents or extracted from seawater during an event, or could have been left by huge tsunamis if in an evaporating environment. The rivers, with their many side streams, form the dendritic patterns as do mountain ranges. They may have formed simultaneously. The valleys, where the main river flows, is where we have mostly a downward flow of energy. At its sides, or better, perpendicular to the main direction, we have mostly an upwards direction. These are the places where mountains are formed. The overall electromagnetic surroundings were probably way different than they are today. The induced electricity was unimaginably strong, and thus the magnetic fields were also acting differently than they do nowadays. Due to the increased electromagnetic field strength, water from inside the mantle rose upwards towards the sky and pulled other materials with it. Gravitation is bound to charge, so it could also be possible that the gravitational pull differed greatly during the event, and whatever material was involved in the event was a different mass than it is today. Simply put, a massive, rather short-lived local electromagnetic fluctuation was involved. Things like rocks or its debris got carried by the winds and fused back into rock in a super ionized weather occurrence. In this kind of weather, we will find all the things needed to create mountains and all what they include geologically. Even the forming of glaciers could have happened rather rapidly. When we speak of severe weather like this, we must take also in account the larger picture. This means we shall not only look into the things which are happening at ground level or in the atmosphere directly above it. We also should take the bigger spheres into our thinking model, the ionosphere, thermosphere, magnetosphere, just to name a few. The turbulences on ground level are triggered and fed with the energy from the fluctuations on a cosmical scale electric circuit. This is important to consider because then it's easier to understand the events happening deep in the ground have a counterpart high in the sky. The possibility of a very strong downdraft wind with really cold air could freeze even the biggest glaciers in minutes. I think these kinds of events are totally possible and have seen before and have even been shown in Hollywood movies. The weather activity from which glaciers are born possibly shock froze atmospheric layers which settled from ejections high above sea level. Some springs broke over time due to earthquakes, or they just lost much of their power, i.e., amount of water pouring out. Some just become lakes which fed a stream. Weather events are related to each other. Many ancient stories tell about them, and often they used words such as dragon to somehow picture the event. They are basically only a reaction and not the event trigger. It is all interconnected. It is all an interconnected chain reaction on the cosmological scale. Nothing happens randomly without a cause. It is just very rich in different kinds of events: fire, water, ice, stone, and wind. These patterns and mechanics repeat over and over on all scales. These kinds of events left deep gashes in the Earth's crust. These are the places where we find volcanoes, lakes, and big rivers. It also left elevated landmarks which still bleed, the mountains with their wounds, the glaciers. They are lava flows made out of water. In some places where the glacier has retreated and reveals what was underneath, we find often patterns which indicate the landmass, the base rock, was once much more fluid. There are many kinds of lava all over the world. One of great interest in Middle Europe, rhyolithic lava. It has a very high content of silica and a low content of ferrous materials. Ferrous materials react strongly with water. This means, basically, rhyolithic lava is somewhat water-based lava, and this would go very well with the intense geothermal potential of the region. In Germany, on the western side of the Rhine River, we find the Donnersberg, Thunder Mountain. The mountain is around 170 kilometers from Kaiserstuhl volcano and around 100 kilometers from the Lach Lake in between them. It is described as being a cryptodome. Like the name already tells, there is something inside the mountain, and since it is associated with magmas, we consider it be a type of volcano. It seems that there aren't too many cryptodomes found yet in Europe. The best known example for a cryptodome is Mount St. Helens in the USA. Inside the caldera of Mount St. Helens is one of the world's fastest growing glaciers. How many cryptodomes are still undiscovered in the Alps region? I think it is important to see geothermal activity as volcanic activity and not as a byproduct of it. As an example, the Andernach geyser, which is located close to the Lach Lake, about 10 kilometers away, has a fountain reaching up to 60 meters, the world's highest cold water geyser. This is proof that we have not only hot water geysers which erupt individually to their own rhythms, but also cold water geysers have eruptions with repetitive time patterns. We should interpret this as an energy wave and not as a random occurrence. Yeah, maybe just a bit, then we go on. Make a third part, I guess. Most of these wells, geysers, or springs are made electrically. So the size of it, amount of the water flow temperature, and the geological situation could provide clues about the intensity of the discharge event. If the spring is small with low pressure and isn't even all the time active, i.e., it has a weak, long interval discharge event, it might not have penetrated deep enough into the ground to make a strong connection to the groundwater. If the spring is big, something as big as a glacier carrying mountain, we are dealing with a much stronger electromagnetic discharge. This also means it might have lasted longer and therefore the material involved got altered electrically from radiation, pressure, and heat much longer. This would create new materials made of other materials. It also mineralizes the ground deep below, forming mineral water. There's a high probability that metamorphosed rock is basically rock which has been the landscape, the environment in which life happened. The rock got altered, transformed, transmorphed, and modified by electricity. This process might have happened to the same rock already many times in the past. We are dealing with recurrent events after all. The intensity of the process might also largely differ, so does the amount of change in the rocks. Its transmuted properties will change according to the amount of energy and time it is exposed to the electromagnetic event. The amount of water included in the process is very important because it will make a huge difference in the minerals formed depending on dry or wet circumstances. When there isn't much water involved, the exposed rock will get burned and it turns dark and even black. If we have a large amount of water involved in the process, things are getting cooled down all the time. Water is something we find in great abundance on Earth, so during an electromagnetic event, equilibrium will bring waters from the ground and the heavens together. Heaviest rain, thickest fog or steam, ground scratching clouds, mixed with all kinds of chemical compounds swirling around in highly ionized supersonic winds. The magnetic fields will attract or repel different ingredients in the clouds, and mountains get fused together. Water, which is dielectric, makes a connection between the particles and is involved in both reactions, the attractive and the repellent action. Okay, this was part 2. Part 3 will be about the floods in Switzerland in 93. Thanks.